Hey everybody, my name is Gabby Silva, and I will discuss the human immune system. What is it? It is a network of tissues, cells, and organs that first tries to keep out germs like bacteria, viruses, fungi, and parasites, and then deals with them if they manage to get in. If it senses something in your body that could be bad for you, it triggers the release of special cells. These travel to where the trouble is, attack the intruder, and help get rid of it. And it does just that. Protects us from illnesses and infections by attacking toxins, bacteria, fungi, parasites, and viruses. So it essentially helps keep us healthy, which is extremely important because without our immune system, we'd constantly be sick and eventually die from a disease or illness. The human immune system works by sending leukocytes, which are white blood cells, to seek out and destroy organisms or substances that can cause infections or diseases. And it does this by using the lymphatic system, which is a network of fine tubes throughout your body that collects fluid called lymph from tissues. Part of its job is to pick up dead cells and germs. Waste is filtered out at small bean-shaped lymph nodes, and the liquid goes back into your bloodstream. An infection can make the nodes swell. You may have felt them in your neck when you had a sore throat or cough. You'd feel a bump right under your chin on the side of your neck, and that is a swollen lymph node, which is a sign of sickness. Your body's fighting something. The human immune system is comprised of two systems, innate and acquired immunity. When you're born, before your body comes across any unfamiliar antigens, it can defend itself from infection. This innate immunity comes from those barrier body parts as well as some specialized cells. Over time, your immune system learns other ways to protect you. Acquired immunity comes from antibodies you get from your mother when you're in the womb, or that you make in response to antigens that aren't yours, like from a cold virus or a vaccine. Phagocytes. They're part of your innate immunity, and they work by eating invaders. Neutrophils are the most common type of white blood cell and are among the first responders called to a trouble spot. They digest bad cells and can trap bacteria and stop it from spreading. Macrophages grow from white blood cells called monocytes, but they work in tissues, not your blood. Eosinophils mainly attach to parasites that are too big to ingest in order to kill them. Natural killer cells. They are another part of your innate immunity in this type of white blood cell. They recognize and latch onto abnormal cells like cancer, then damage and kill them. They're key players when you first get infected by a virus. Basophils and mast cells. They're also part of your innate immunity, involved with allergic reactions. Basophils are in your blood. Mast cells are in tissues. When these cells find certain antigens, typically harmless things that your body sees as a threat, they release histamine to bring immune systems to the area. Your body sends more blood there, causing inflammation, which is redness, warmth, and swelling. That also helps keep the invasion from spreading. Lymphocytes. These infection-fighting white blood cells are the reason you get sick from things like chickenpox only once. Lymphocytes, called T cells and B cells, work together to build your acquired immunity. Antibodies. Once your B cells get a read on the antigen of a new invader, they make antibodies to either kill it or flag it as trouble here. These Y-shaped molecules fit into antigens like puzzle pieces, making an immune complex. An antibody can also be called immunoglobulin or Ig. T cells. They travel through your blood and lymph systems, waiting to be activated. Usually, another immune cell, like a dendritic cell, will need to break down an antigen so it can be recognized to start the process of making specialized T cells. Killer and helper T cells are part of the search and attack team for that antigen. You need suppressor T cells to end the response, and they can sometimes prevent harmful responses from happening. Thymus. After forming in your bone marrow, T cells travel to the small organ behind your breastbone to mature into cells that can tell one antigen from another. It's also here that these cells learn not to attack your own body's tissue, and they normally can't leave the thymus until they learn this. Secondary lymph organs. Your spleen, tonsils, adenoids, appendix, and small Peyer's patches in your intestine are where mature T cells are stored. These organs can also help sift out germs and dead cells, the way your lymph nodes do. Your immune cells might meet up here to get a closer look at possible threats and figure out the right plan of action. Memory cells. You may get sick the first time your body comes across a new antigen and is learning how to make antibodies, but afterward you'll have leftover B and T cells called memory cells that can recognize that particular germ and respond quickly. Complement system. It's a group of more than 30 proteins that work in a cascade, where one triggers the next, which triggers another, and so on. These either kill germs directly or mark them on or their location so that other cells can destroy them. They may help antibodies do their job. They're also part of cleaning up immune complexes and the antibodies attached to antigens. They work with both acquired and innate immune responses. Cytokines. Different kinds of cells can make these messengers. Some cytokines trigger and focus the immune response. They might tell white blood cells where to go or how to destroy a particular germ. One type, interferons, can slow or stop a virus from making copies of itself. Cytokines also tell your body to shut it down after a threat is gone. When it goes wrong. An allergic response is your body overreacting to something that wouldn't hurt you, like peanuts. When your system doesn't react strongly enough to a problem, that's called an immunodeficiency disorder, like AIDS. An autoimmune response happens when your body mistakes your tissues or organs for invaders and attacks healthy cells. That can cause serious illnesses like rheumatoid arthritis, Crohn's disease, type 1 diabetes, and lupus. In the last year, scientists have realized that a gut bacterium, Enterococcus gallinarum, may be used as a treatment for APS, antiphospholipid syndrome, which is when your body attacks itself. This gut bacteria can spontaneously translocate, which stimulates the production of autoantibodies, which causes inflammation, which is good because this is an autoimmune response, which is what APS lacks. How to keep your immune system healthy, which is extremely important because you do not want to get sick over and over and over again. It's simple. Eat plenty of fruits, veggies, and whole grains. Exercise regularly. Wash your hands. Don't share beverages. Get enough sleep. Reduce your long-term stress. Just take care of you. Take care of yourself. Give your body the energy and the time it needs to focus on healing itself. So don't stay up late. Don't share a bunch of drinks with a bunch of people you don't know. Don't go kissing a bunch of people. Just make sure you're taking care of you. Because if you don't, you can get something like mononucleosis, otherwise known as mono, which is what I had a couple years ago, and it really sucked. I was sick for 8 months. I had the cold several times. I had the flu several times. I was stuck in bed for weeks, for almost a month straight, because I physically could not get up. My immune system was completely shot. And it super sucked because I'm a people person and I didn't like to be stuck in bed. And all of that happened because I wasn't taking care of myself. And I wasn't sleeping well. I was overwhelmed at school and work and XYZ. I didn't practice good hygiene, and so I got mono and my immune system was basically non-existent. So take care of yourselves, guys. It's really important. Thanks. Have a good day.